Hi, I'm really excited to start this discussion today because I have with me two really one of the greatest names I can say in data and AI today. They're both published authors and they're amazing people, and they're also the opening keynotes to the sixth edition of the Data Innovation Summit. So I have many questions for you today, many topics we'll discuss. So to start with, can you please tell us a bit more about yourself so our viewers can get to know you? Stephen, would you like to go first?
Sure. I'm the Chief Technology Officer at Teradata. I've been focused on data pretty much for my whole career. Originally, the focus was in scientific computing and using large data sets for weather prediction and finite element analysis and hydrodynamic simulations and so on. And then slowly I moved into real-time trading on Wall Street, and then eventually into what we now call data warehousing, although it wasn't called at that time data warehousing, but it's what we now say. And my PhD research at MIT focused on massively parallel processing architectures and workload management. And I focus a lot on my clients with the clients on how to think about using information strategically and machine learning strategically for driving business decisions. But of course, at the foundation of that is data and making sure the data is helping you get the best answers to the questions that you're asking.
Right, awesome. Bill, can you tell us about you?
Yeah, I'm pretty simple. I'm a teacher. So I teach at universities. I run lots of lectures and classes for organizations of all size, corporations and nonprofits. I think at my heart, I'm a teacher. When I write to share and teach. And I am currently the at Dell Technologies, where I'm the customer advocate in our area around data management innovation.
Right. Yeah. Thank you. So we know that everyone is talking about data and AI and transformation and innovation. And the central theme of the Data Innovation Summit is actually how can we accelerate AI-driven transformation. But how do you see the data and AI maturity among organizations today? How would you assess it? Stephen,
I would
would you like?
say I would say that data maturity is relatively high. We've been at this for quite some time, but it varies widely across organizations and industries and so on. So you can't uniformly say it's high, but most organizations have been at this data thing for at least a couple of decades. And so they're starting to understand certainly the importance of it, but understand that, you need detailed data to make good decisions. It's not about summarizing data and dashboards and reports, and need to get beyond that simplistic thinking. So I would say data, yeah, relatively high maturity. For AI, I would say relatively low maturity. We're very early in the stages of AI. My cynical view is AI is more of a marketing term than a reality term these days. It's a big umbrella of what is AI, right? Underneath AI, there's natural language processing, there's machine learning, there's deep learning, there's robotics, there's all kinds of things in AI. So whenever someone says AI, I say, okay, what are you really talking about here? We need to narrow down the discussion to have a meaningful discussion on this topic. And so there's a lot of, attention, a lot of hype, a bunch of proof of concepts and so on, but what's being done actually in production at scale has a wide variation across organizations. Some have lots of very, very interesting high return on investment kind of things going on. Others are still putting their foot in the water. So high variation, which is a sign of immaturity when you're at that level of variation across organizations.
Mm-hmm, mm-hmm. Interesting. Bill?
Yeah, I agree very much with Stephen. I think his one point that I'd like to even expand further is it's not the volume of data that's interesting, it's the granularity, right? It's the fact that we can get down to building very individualized models that predict behavioral and performance propensities. I call that nanoeconomics. I've written quite extensively about it. I think it is one of the aha moments for people who cross the chasm and realize that if you make decisions based on averages, at best you're going to get average results. And I agree with Stephen on the AI maturity. In fact, I think we struggle from an AI definition. It seems like everybody you talk to has a different definition of what is AI, and it can vary greatly. The one area that I think is a big challenge for us is around data literacy. So I think that overall our data literacy is very low. I spend one of my sessions in the class I teach at the university is all around data literacy and AI ethics. And it's people just don't realize what data is out there, what data is, and how much of their life is basically totally exposed. So I agree that we've had data a long time, and and certainly old data dogs like Stephen and myself understand it. I think that there is still this struggle across maybe society more than corporations around data literacy.
And I want to pick up on your point around ethics. That this is a really important point. And to me, it's a sign of maturity in an organization where they're beyond the which algorithm should I use and so on. And they're starting to think about ethical use of the data and ethical AI, meaning, are we introducing bias in our algorithms for approving someone's credit rating or even making the product offer or pricing and so on? There is inherent bias that is very prevalent in a lot of the AI algorithms that have been deployed, and organizations are not really aware of it. So if they're not aware, then they don't count as mature in my mind. They're still in the early stages. There are well-known and published algorithms, even open source, to help people understand where there's bias, but I don't see it as widely used as I would like to see it in our society. People think, oh, it's the computer making the decision with data, and therefore there's not bias. Humans have bias, but computers don't have bias. Well, that's in some sense true, but humans are the ones that are doing the data set selections for the training sets. Humans are the one building the models, setting the objectives, and there are lots of opportunities for humans to, I'll say, inject their own bias into the AI algorithms, even without knowing it. I'm not saying they're doing it on purpose, but without knowing it, those biases sneak in, and it can have a very detrimental effect. In fact, the World Economic Forum, they identified ethics and bias in AI as the #1 inhibitor toward widespread deployment and acceptance of AI in our society.
Well, yeah, that's definitely one of the greatest challenges. But as you also mentioned it, how do you think organizations can tackle this bias? How can is also connecting to what Bill said? How can they increase their data literacy and in turn aware of bias and how to tackle it?
So so Stephen hit it really well. If you haven't addressed AI ethics, you're not very AI mature. And what we're seeing is the AI models will do exactly what they're programmed to do. They will perform exactly based on the AI utility function, the variables that you define for it. And what we see is that we shortcut that. So, if you're a social media company, you optimize on likes and shares and tweets and et cetera, and you end up with this problem of, because you've got so few variables, you end up with what we call confirmation bias in the models. The models just keep serving you the same content over and over again, which has all kinds of potential political issues and such. And so for AI to be more widely adopted and to overcome some of the ethical issues, we need to have a very diverse set of variables around which the AI models are going to try to optimize. It's not just operational or financial or customer. It needs to take in environmental. It needs to take in society. It needs to take in diversity. And I'd even argue it needs to take in spiritual in some aspects. So how we define the variables around which the model is going to optimize becomes critical. And those are the value statements, the KPIs and metrics that we're trying to have the AI model optimize. The second point I'd like to make on this is around confirmation bias. If you don't instrument your AI models to understand, measure, and instrument and measure the false positives and false negatives, then the models don't ever learn. The beauty of an AI model is that it learns from what it's done in the past. And if it's made mistakes and you tell it makes mistakes, it takes that in and it gets smarter over time. Not maybe as fast as we'd like, but if you don't instrument for the false positive and false negatives, then you end up with this model that just keeps driving down confirmation bias. And the interesting, sad aspect is from a corporation perspective, when you have that that confirmation bias creeping into your messaging, you actually miss customers. Your total addressable market starts to shrink because now you're only talking to the same customers you've only ever talked to, and you're missing all kinds of other customers on the peripheral who could be very important customers to you.
I think this point of measuring the false positives and false negatives is critical, because without that, you have no visibility when bias is sneaking into the model. People often have the misperception that, oh, I don't have bias against race because I don't have a variable called race in my feature set, or I don't have gender, I don't have age, or I don't have religion. Because I don't have those features, those variables in the training set, therefore I don't have any bias. That is completely false, right? I can look at your clickstream data, and I can, with very, very, very high accuracy, determine if you are male or female, if you are black or white. I can determine your age. I don't need to have those variables explicitly. There's all kinds of indirect ways. And believe me, the machine learning will find those correlations, right? Whether you want them to or not. So the point that Bill made about measuring the outcomes and then comparing them to see if there's bias, if you are, more often having false positive, false negatives to one group of people than another group of people, you have a problem, even if you didn't have that indicator in your feature set. Right. So this is very, very important. And this confirmation bias that Bill mentioned is a big problem, because, data scientists, they're trying to do the right thing, and they're building their models, and they want them to be correct. And of course, that's taking pride in their work. And one of the things that I always recommend is that you should have a team, which are the team looking for the bias, looking for what's wrong with the model. Because the people building the model, they're going to have this confirmation bias. They're going to think the model is correct. That's natural. If it's your work, you're going to think it's correct. So you need to have a separate team, maybe even a different part of the organization under compliance or auditing, that comes in, and they're not going to be the most popular people on the team, but that team has to be looking for the cracks in the pavement where we've got potential problems in the model, and having that be independent from the team that is building the model is actually very important. The other thing is that team building the model, that team should be diverse, right? If you have a bunch of middle-aged white males building machine learning models, and I say that because I'm from Silicon Valley, and I'll tell you it's a big problem. Right. For example, the gender diversity in the data science teams that build these models is not where it needs to be. And when you don't have gender diversity or race diversity or age diversity and so on, then the people building the model, they have built-in biases. They're not doing it on purpose, right? But those biases sneak into the features that get selected and the data sets that get used, and it's a problem, right? So we need to have diversity in the data science team in order to have at least one way of fighting lack of, I'll say, diversity or inherent bias in these models we're producing.
Yeah. So we started talking about data and AI transformation innovation, and we continue to bias and how organizations can tackle it. But when we talk about data and AI transformation, there's also one question that arises that is also actually the one of the underlying theme of that innovation summit is how businesses can transform from data-driven businesses to algorithmic businesses. How do you see this transition happening, and what is needed for that to happen?
Well, I would say that, even if you're algorithmic driven, you're still data driven underneath it, right?
Yeah.
So the algorithms is a layer on top of the data. And if you have, unreliable data pipelines or unreliable sources of data and so on, the execution of the algorithm is not going to be very useful. It's kind of garbage in, garbage out. If you put bad data into your algorithms, you're going to get bad answers out. So I don't look at it as moving from one to the other. I look at it as layering on top and getting more leverage from the data. Because when humans are using traditional BI tools and visualization tools, there's still, I'll say, very slow learning process. If a human has to do all the learning on their own, you want to use machine learning algorithms in order to do the learning more quickly. But it doesn't mean that you're going to necessarily completely replace. So algorithmic driven can be a little bit dangerous. When we talk about AI, you can define that as artificial intelligence. Very often, I will redirect that acronym to say augmented intelligence. In other words, how can you use the algorithms to help humans be smarter and vice versa? The algorithm by itself can be very, very efficient, but maybe is not going to be as accurate and as insightful as a human can be working together with the algorithm. By the way, a human working by themselves is also not going to be as good as the human and the software or the algorithm working together. So this idea of augmented intelligence, particularly in critical decisions like healthcare, for example, where there's so much input data and so many contextual sources of information, the algorithm by itself is not going to be as good as doctor plus algorithm together.
So Ivana, the transition from data driven to algorithmic driven, I think is BS. I think it's totally the wrong way to look at it. I think telling people that's the way they got to focus is wrong. And the reason why is I think the conversation has to start around value driven. It has to start with how does an organization measure value? How do you articulate value? What are the variables, KPIs, and metrics against which, as an organization, you're going to measure your progress and success? That's got to be the starting point. Now, if I understand that, it helps me figure out what algorithms I need. It helps me figure out what data I need. But algorithms without a sense of statement around the value, it gets back to the problem that Steve and I were talking about earlier around confirmation bias and such in the AI models. It really must start with how does your organization define the variables and metrics against which you're going to measure progress and success. John Smale, who was a CEO at Procter & Gamble back in my days when I was working with Procter & Gamble, used to always say, you are what you measure and you measure what you reward, which is basically his way of saying, as an organization, we are what we pay our people to do. And so, yeah, you want to measure these wide, diverse set of things, but if you really want to get down to an organization's value statement, take a look at how they pay people. And then that's how an organization wants to optimize. They're trying to optimize how people get paid. So anyway, we can spend a lot of time talking about the importance of being value driven, of defining value, the effort you have to put in, the necessity to bring in a diverse set of perspectives, which, by the way, is different than a diverse set of opinions. Diverse set of perspectives allows you to figure out, how do I balance across all these different variables, some of which actually conflict with each other? But that's what human nature does. We make decisions every day with variables that conflict with each other. We have to wrestle with that. And the AI machines need to do the same thing. So anyway, don't mean to be tossing the snake into the kiddie pool, but I think when, data-driven to algorithmic-driven is nice, but let's really start with value-driven as the starting point, and then ripple everything back from there.
But this value-driven discussion directly relates to the sustainability discussion, right? Because if what we measure as the outcome, the objective function of our machine learning is profitability and nothing else matters, then the machine learning is going to optimize for that. And so we need to, think about sustainability as part of the value proposition, right? So it's not just about how can we squeeze more profits? How can we, yes, be profitable, but in a sustainable way, so that we measure outcomes along multiple dimensions. So as we become more sophisticated in machine learning, we don't have a single, output variable that we're optimizing toward, but a panel of variables. And then we have to say, okay, what is the balance between those? Because, if we are totally sustainable but unprofitable, then we go out of business, and then we're not sustainable either. So, we have to have a sustainable society. We also have to have a sustainable organization. And so we've got to get a balance between those things. And as we start evolving how we think about what is success for the organization, that will inform, how we define our objective functions in the machine learning algorithms. And that is critical to this sustainable society discussion and the use of data for creating a sustainable society.
And that's the beauty of an AI model. It will continuously learn and adapt. So in Stephen's example, right? If you start going unprofitable, then it has to adjust accordingly. If you're not meeting your diversity objectives, if you're not meeting your environmental objectives, right? If all these different things that factor in, there is no one right answer. It's like it's like a guided missile, off target, off target, off target, off target. And it's always constantly adjusting itself. And that's what happens in these AI models. There is no single right answer. And so it has to continuously learn and adapt based on what's happening in the environment around it. And, you have a pandemic, you have California wildfires, you have the Zodiac killer, right? All these things come in and your models have to adapt accordingly.
Well, the point is that whatever the right answer is today is not going to be the right answer tomorrow, right? And the pandemic taught us this very clearly because, pre-pandemic, people had highly optimized supply chains, but they were very fragile. And so when everything changed, you had this black swan event and everything blew up. And people didn't know how to adapt for that. And the organizations that were most successful were the organizations that could use the data to learn dynamically and adapt. So the goal is not to over optimize, to a right answer. As Bill pointed out, there are many right answers. The goal is to build a capability where you can adapt very quickly. And that adaptation should be informed by data, detailed data, so that adaptation is also going to be customized to the situation, because the pandemic may have a very different impact in Europe versus the US versus Australia, right? And therefore the actions that you take need to be very different. And so this is, understanding the detailed data and also understanding that there may be different objective functions. So in Sweden, they made very different policy decisions about how to deal with the pandemic and how to create objectives to optimize than in Australia, for example, which are two extremely different approaches. You can't say that one is right and one is wrong, but you can certainly make sure that we're measuring the outcome and then we learn from those experiences and adapt.
Great. We've heard really great points so far and insights. But one point that you mentioned, Stephen, was about how the impact of the pandemic and how it impacted America, for the United States and Europe, for example. So regarding this, what are the trends you see developing in data analytics, data management, recent trends? And are there any different from the United States and Europe among organizations?
There certainly are differences, but there are some common themes. So one of the common themes, which is true across Europe and the US, is the desire for more up-to-date data. In the past, a lot of times we're working with data that we loaded, last night or even last weekend. That is really unacceptable today, right? So you want to be able to have data ingested on a continuous near real-time basis. And as we both said, at the detail level. And I say detail, but I'm gonna talk about, we used to consider detail the transaction level. Every purchase, every phone call, every event that had a monetary value. But we need to start thinking about not the transaction level, but the interaction level. In other words, not the atomic detail, but the subatomic detail, right? What are all the interactions that led up to that event? So for example, a transaction level detail in healthcare is, I went to the hospital, I had this diagnosis code, this procedure code, there might be multiple line items of the drugs that I took and so on. That would be the transaction detail. But the interaction detail are all of the measurements that were taken about my temperature, my blood pressure, and so on. And as our society advances, you're going to have the ability to collect that data on a continuous near real-time basis. And there's already primitive versions of that today with, Apple Watches and similar types of consumer devices. That will become more prolific. It will, today the problem is that people that wear those devices are probably the ones that least need it, right? Because they're the health freaks that probably are, very, already very fit and so on. We need to have widespread adoption for the people that maybe aren't so fit, they need to start wearing. And yeah, okay, maybe you don't want the bad news, but you need the bad news, and you need to, be able to continuously improve your situation. So the point here is that we need detailed data and detail at the subatomic level, and that's going to be true in Europe and in the US and in other societies. Now, Europe is, I would say, ahead of the game in thinking about the ethical uses of data versus the US. GDPR and some of its predecessors have been around for a long time. In California, which is where I'm from, we just recently passed the California Consumer Protection Act on data, CCPA. Decades after GDPR was first introduced, although they didn't start enforcing GDPR until more recently. But Europe is clearly leading the charge related to ethics and use of data and so on, and the U.S. is typically following. On the other hand, if you look at deployment of cloud, this is where the U.S. is definitely a bull, leading the charge there. Pretty much every organization that I'm working with across pretty much every industry is figuring out how they can get to the cloud and how fast they get to the cloud, and figuring out how to take advantage of all the innovation possibilities in the cloud, because you can fail much faster and cheaper and learn much more quickly in the cloud, because there's no innovation overhang when you have to buy capital assets and bring them into your data center and so on. In the cloud, you bring up the resources, you do the experiments. If it doesn't work out, you shut it down and the cost goes away. It's beautiful. So innovation accelerates in the cloud. And I think the US has been much more aggressive about deploying in the cloud than in Europe. But of course, Europe is certainly, at least in certain industries, being relatively aggressive about it. But there's, we learn from each other, right? The Europeans are ahead in some areas, the US is ahead in some areas, and not to mention, in APJ, they're also, innovators in certain areas, especially the use of data in manufacturing, and some of those areas are very advanced in the Asia Pacific Japan region. So
I think that's a great answer. I have nothing more to add. I think that's good.
Great. Well, speaking about trends, there's definitely one trend that's catching on really quickly at the moment. That's actually one of the hottest topic in data analytics. It's data mesh. What's your opinion on this? How will it transform companies? Will it aid in data-driven transformation?
I think it's absolutely, transformational. And what I would argue is that it is the natural evolution from where we've been. So in the beginning, these enterprise data warehouses, when an organization's first learning how to do it, they centralize the team. They centralize the data modeling, the data stewardship, the provisioning and ETL. Everything is centralized to some quote unquote data warehouse team, and they build the structures to be successful. And because we've been successful, centralization doesn't work anymore. Right? Because at the same time that you have this centralized team, the number of data sources is exploding, not just internal data sources, but also external data sources. The number of consumers of data is exploding. And in the middle is this centralized team trying to keep up with the explosion of data sources, explosion of they can never be successful. And so, data mesh, people think of data mesh as a technology. It's not a technology. That's where people get confused. It's not a technology. Data mesh is really an approach for how do you think about decentralization of the ownership and align those to the business process owners, right? Where the subject matter expertise lives, and bring and bring the responsibility in that way. And then you can decentralize, and then they can be much more agile. They can proceed in parallel. They know what the requirements are for their data, and they can be much more successful in creating data products that are consumable. Now, I want to be a little bit careful here, because I don't want to imply that I'm suggesting that you want complete anarchy, right? Because if we decentralize everything, you get complete anarchy. We need we need guardrails. We need some level of, enterprise thinking about how we're going to do security and authorization and access controls and so on. This is not something you want to be anarchy, right? We should have guidelines around, naming conventions and data typing and so on, just guardrails. I'm not talking about doing the detailed data modeling centrally, but at least some guardrails. So again, you don't have complete disconnection between the different schemas that are deployed. So the way I think about it is each one of these decentralized teams is going to deploy a schema aligned to the data, for their data process. But it is important that we can connect the schemas. So having referential integrity between the primary and foreign keys is really important. So we need to have, some enterprise level guidance there. There will be some, I'll call them enterprise schemas where, yes, I need customer and I need customer's relationship across, mortgage and credit card and DDA. I need that enterprise customer. Now, some of the super type information about a customer, which may be different across those different processes, should be promoted into an enterprise schema, even if some of the things that are very specific to a business process might live within the schema aligned to that particular business area. So you want to get the right balance between enterprise centralization versus decentralization. And right now the pendulum is too far centralized. We need it to swing to decentralized, and that's what data mesh provides for us, but not so far that you create anarchy. Right? This is absolutely critical for success. And sometimes the pendulum goes too far, and then you get into trouble. So we got to get balance on this. And again, data mesh is not technology. It does not imply that we must have distributed databases or that we must have, every schema has to be on a different technology. It very well might be because of sovereignty rules and other rules. But, if you can co-locate the schemas, physics works better when you move fewer bits, less distance, right? So don't think we're going to deny the laws of physics because we have a fancy name called data mesh. Again, think of data mesh as organizational more so than technical.
So I'm not going to address your question at all, because I think what I see the most advanced organizations from a maturity perspective, from a data and analytics perspective, are adopting a hub and spoke kind of organizational structure. There's underlying technology to support it, but what's happening is that they're putting their analytic teams both along with the business lines of business leaders, but also a centralized organization, and they have very different responsibilities. In fact, you even have a rotation of people through that. The reason why you want people out in the businesses, I'll call that the spoke, because at the spoke you're co-creating data and analytic assets. This is where value is being created. You're solving real business problems, but you don't want to have orphaned analytics. You don't want to have data silos. You don't want to have these one-off efforts, bespoke efforts. So while you're creating these data and analytic assets in a co-creation environment at the hubs or at the spoke, at the hub, you're taking these things in and they're being engineered into composable, reusable, continuously learning and adapting analytic assets. These are assets that are continuously being reused. This takes advantage. When you have this sort of structure, it's very much an economic model. Because I can build, you think about data from an economics perspective, it never wears out, never depletes. The same data set can be used across an unlimited number of use cases at zero marginal cost. It's got a lot of great aspects to it, right? So you don't want to have data silos. But in the same sense, you don't want to have orphaned analytics, because orphaned analytics soon become liabilities, because Bob, who wrote this thing, is now moved somewhere else and no one knows how to tweak and modify this. So you really need to engineer these assets. And if you engineer these analytic assets in a way so that they are composable and reusable, they can continuously learn and adapt and be used across an unlimited number of use cases. And any time you make an improvement to that analytic module, you improve it by 0.1%, its efficiency and its predictability. Every use case that uses that all of a sudden got 0.1% more effective at zero marginal cost. So to me, what is interesting here is what leading organizations in this hub and spoke place, our organizational structure put in place, and they're very much focused on how do we build data and analytic assets, co-create at the spoke, and then engineer at the hub for reuse, right? So it allows us to take advantage of the unique economic characteristics of data that never depletes, data assets, and then analytic assets that can actually continuously improve in value, get more valuable the more that they are used.
Nice. Since you already mentioned the economics of data, let's talk about your Data Innovation Summit topics a bit. So, Stephen, your Data Innovation Summit topic is on data and transparency are the keys to sustainable societies. And Bill, your topic is on the economics of data analytics and digital transformation. So, is there any way these two areas, let's say your topics, correlate with each other and can help each other achieve goals, or do they have any touching points that they can, as I said, help each other? What do you think?
Well, I think this goes back to the value discussion we had before. So economics can be measured in many ways. So economics can be measured in the profitability of the company, but it can also be measured in what is the positive or negative effect that you can have on society, on the ecology, and so on. So if we think about economics in a more broad way than just the profitability of the bottom line, then it becomes an interesting discussion, right? And so part of the discussion that I will have in the conference is how do we think about widening the things that we're optimizing for beyond just euro profitability into sustainability for society along a number of different dimensions. So if we can create an economic value to sustainability, then it becomes an interesting discussion.
And what I'd add to that, agreeing with Stephen said totally, is you think about it, the economic utility function and the AI utility function virtually are the same. They're the same. They could be, right? How you define economic value. You mentioned that there are obviously, there are financial ramifications, there are operational, there are customer, there are environmental, there are society, there are diversity that impact both how your model should be defined as well as how you measure value. So what I find most interesting about this conversation, why I wrote about it, is that these two topics they blend into each other. But if you end up with orphaned analytics that don't get reused, they become liabilities. If you build data silos that can't be reused, you build in liabilities. And so this idea of creating a holistic environment, very transparent, so you know where the data is, and you're engineering your data and your analytics in a way so they can be shared, reused, and continuously refined. That's how you exploit the unique characteristics, economic characteristics of data and analytics.
So since we're slowly running out of time, and
slowly,
slowly, yeah, which is actually fast if you're having great time and being in such a great company. Let's say, what are your predictions, so to say, about data analytics and AI in the near future? What do you say we're going to see in the next couple of years?
A couple of years is a pretty short amount of time in the scheme of things. So I think, in the next couple of years, you'll see, more widespread adoption and so on. But I think the more interesting point is if we go beyond a couple of years, you're going to see machine learning. And so I'm going to narrow AI into something more specific to machine learning. You'll see machine learning embedded to almost every decision made in an organization. So rather than having a special team of data scientists working on, projects, every team will be embedding machine learning into every process. Decisions made around, maintenance of machines, or, what recommendations you make to a customer, what color you design the product to be, and so on. Machine learning will be involved in all of those things. Now, these will be for, very specific, targeted decisions. The idea of, a general AI capability or broad AI, this is many years away, right? So, I'm working with a bank in the financial services area, and one of the discussions is, well, how soon can we replace a financial advisor, with an AI bot? Well, replace is a strong word, but we can certainly improve the financial advising capability of the organization, because with and I'm going to use again this term, augmented intelligence. With data analytics, we can figure out, based on for this particular customer and the portfolio of products they have and what their objectives are and so on. Assuming you collect that data, we can make very good recommendations, and the machine learning will be the foundation of that. And then we have to communicate to the customer and have kind of a conversation about that. That conversation, we can increasingly do with bots, and we can do it with chat, and also voice to voice is getting better. These things will start to proliferate, but it's going to take more than a year or two before we completely replace the human aspect of that.
What I would add is that AI eventually is going to impact every career and every profession. Everybody is going to be impacted by it. I love Stephen's, AI is augmented intelligence. And so what's going to have to happen over the next 2 years, but beyond, is AI literacy as well as data literacy needs to be taught to everyone, not just your undergrads, not just your high school students, not in, middle schoolers already. Heck, a middle schooler knows more about how to calculate WAR and baseball than I do, right? So there is a natural propensity that people have, I think, to understand and learn this better. So we've got to make AI literacy and data literacy a foundational skill across everybody in this country. Otherwise, we will end up risking having a bifurcated community, a world, right, where people who either understand it and can work with it and leverage it and prosper with it, and those who are afraid of it for whatever reason, and it ends up putting them on an unfair footing. So to me, I think what the trend I'm seeing is that AI literacy becomes something for everyone. Maybe it becomes a coloring book. I don't know, but that's where we're headed towards.
Definitely, we'll see that. But some great points we've heard today. We've covered really important points about that data and AI transformation, and we quickly touched upon your Data Innovation Summit topics. So with that, I'd like to thank you for taking the time to do this interview with me, and I look forward to your sessions at the Data Innovation Summit.